In this video we're going to look at angles, parallelograms, triangles, okay, and some of the basic rules associated with them. First thing we're going to look at is the types of angle. So here we have an acute angle, and an acute angle is anything less than 90 degrees. Then we have a right angle, and that's always 90 degrees, and you'll see that by the little square that's in the angle. An obtuse angle then is anywhere between 90 and 180 degrees. The reflex angle, anything greater than 100 degrees, and the straight line is 100 degrees. So let's just look at some rules. The first rule we have is here, and it says vertically opposite angles are equal in measure. So really what we're saying is, if we have two straight lines crossing each other, well, their opposite angles are the same. So A equals C and B equals D. Over here then, angles at the point add to 360. So what we're saying is all these angles add to 360. So A, B, C, D and E would add to 360. Over here then, angles on a straight line add to 180. So these three angles add to 180. So I'll give you an example of this. Let's say this was 50 degrees and this was 70 degrees. Well, if I add the 50 and the 70, I'll get 120, and if I take the 120 away from 180, I would get 60 degrees. Okay, I know that's 60 because these triangles have to add to 180, and they do. Next we look at parallel lines. If I have two parallel lines, and I know lines are parallel if they have these arrows on them, so I'll put them in here as well. These are parallel. These are parallel. This red line here is cutting the two parallel lines. That's called a transversal. And parallel lines with transversals running through them have some interesting properties. For instance, these angles here are the same. They're called corresponding angles. We look for the F sign. Okay, so you probably remember that. So if you look for the F here, and the angles then underneath the F, so here and here, they're the same. We could also look at drawing that line again. We could also look at maybe this side over here, and it's a backwards F, and this angle here will be the same as this angle here. Also this angle here is the same as this angle here, and this angle here is the same as this angle here. They're all corresponding angles. Over here then, we have alternate angles. We're looking for the Z shape, okay? So alternate angles are equal. So if we see that Z shape this way, and we look at the angles inside the Z there, they're equal. Also we could look at the Z shape this way. Okay, and I could say then this angle is the same as this angle. Again, they're alternate angles. Over here then, we have internal angles. So the internal angles, the ones inside two parallel lines, they add to 180. Next, if we look at the triangles. So if we look at this, the angles of a triangle add to 180 degrees. Okay, so we can solve questions like that. If I have a triangle and I have 60 degrees, 90 degrees, and they ask for this, well, I'll add the 60 and the 90, I get 150, and if I take 150 away from 180, I'll get 30, so I can find out that that's 30. Over here then, the exterior angle of a triangle, which is this, equals the sum of the two opposite internal angles. So the sum of the opposite. So opposite from D is here and here. So in this case, B and A equals D. Okay. And over here we have an equilateral triangle. An equilateral triangle has 3 equal sides and 3 equal angles, and each angle is 60. And sides are shown to be equal by these red kind of slits. If we look here, an isosceles triangle. An isosceles triangle have 2 equal sides. There they are, and the base angles are equal each other. So there's the base angles. I suppose a good way to remember which angles are equal each other is the angle that both of these equal sides run into. Okay, so they're both running into that side. Well, that's not the same. The other two are. And lastly, then this one, a right angle triangle has 90 degrees. And when we're dealing with right angle triangles, we'll be dealing with this, which is Pythagoras' theorem, and the 3 trigonometric ratios, the cos, sine, and tan. We look at quadrilaterals then. Quadrilaterals are any 4-sided shape. And the 4 angles of a quadrilateral, so here, 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 add to 360. Same as here, 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 360, and 360. Lastly then we look at a parallelogram. A parallelogram is a quadrilateral. However, it has 2 opposite sides that are the same length and they're parallel to each other, and it has 2 other sides, top and bottom, which are parallel to each other and the same length. It also has 4 angles, and the opposite angles equal each other. So B and A equal each other, and D and C equal each other. Okay, thanks.